not the symposium, so this presentation was like something alone than other disciplines. But I think it's very good opportunity to show some very interesting topics from the behavioral analysis that is very close to the ecological psychology. And you will say if that's right or if we are wrong. Well, the behavioral analysis as an allied discipline to the ecological psychology. There are different topics that we call to say, for example, there are work from people from the ecological psychology that is presented in the scenarios from the behavioral analysis. For example, the Journal of the Experimental Analysis of Behavior, a paper from Alan Costal that talks about the book of the ecological approach to visual perception of Gibson. This is an example. Another example from another side, Edward Morris is a behavioral analyst that makes a review of the book of Harry Heft, Ecological Psychology in Context. Yeah? Another very interesting topic is developed in behavioral analysis is Jeff White from New Zealand developed a model for studying memory in the behavioral analysis, but based in the theory of direct remembering notion of the Gibson's analysis of direct perception. So there are a lot of very interesting influences and meetings that are producing work. But, well, it's interesting, but not this for today. Another topic is Skinner has a development about approach to visual perception. Is it true? Maybe he says in 53, the visual field is the occasion for effective manipulatory action. And we develop the behavior we have built a spatial world because visual stimulation from an object is the occasion upon which certain responses of walking, reaching, and so on lead to particular tactual consequences. There are interesting topics from the Skinner, but interesting but nature for today. Because for today, I think it's more interesting here. It's the affordance analysis in operant settings, pressing the lever. It's like to observe in the Skinner box, you could analyze the affordances. Is it possible, or is it another kind of behavior by itself? Well, so this is our main topic. But all you know involved and you think right. Well, no think. To introduce this topic is, well, all you know, the basic structure of operant behavior is, well, this is the previous stimulus, the discriminative stimulus, like a light, a sound, the lever. After the response, pressing the lever, and the consequence, the reinforcer, is the food, water, or something like that. The emphasis of the operant behavior is the reinforcer. This makes sense for what the stimulus, the discriminative stimulus, and the response is framed by the reinforcer. Is the main proposal for the operant behavior. Well, what happens if you eliminate the reinforcer? We found that behavioral analysts speak about the operant level. In this situation, the operant level is called the responses emitted before conditioning. There is a lever, it could be pressed, and no consequence, the reinforcer. That's the operant level. But existential question for the behavioral analyst. What does a behavioral analyst do without reinforcers? Maybe they distinguish. This is before the procedure of condition, not after. It's not extinction. It's before condition. The behavior analyst maybe doesn't have job if there are no resources. Well, what has been done? It has been used, the open level has been used for methodological concerns like baseline performance. It has been like some measures about the open level like response duration that are longer than responses during conditioning. The lever pressing is more forceful before conditioning. One more is lever pressing increases with psychostimulants. And etc. But the story is over. Note the years. Note. Very old term. There are not so much to do with that setting. A lever, responding to the lever, no reinforcement. There is not so much to do with that from the point of view of the behavioral analysis. But the alternative, my colleagues and me made an experiment recently studying the affordances in the operant setting. We suppose that the lever is a potential support, affordance, for erector postures while leaning against the wall. So for this experiment, we compared two sizes of subjects, big subjects and small subjects. Here is the situation is the various lever heights provide different postural support during exploration. Therefore, different response frequency. So the lever at this height could afford different behaviors while leaning against the wall when it is in this height or in this height. We have different heights of the lever and different size of subjects within a operant setting. What we observed was, well, the big guys were the rats. We had this height of the lever, 30 millimeters, 72 until the 204. We observed a very nice distribution where in this height there was more responses than the rest. We'll see if it becomes why after. But after this, we have a very nice distribution of the responses. At this height was more, the level at this height maybe invited more responses than the rest could be. And the latency was the opposite, was more latency for those heights that were, so the rat emitted less responses, and the rats began to respond quickly in those heights that were more, there were more responses. So this complementary data in general. What happened with the shorter guy, the hamster? We compared rat, hamster. Well, the hamster are shorter, so they come to press the lever at the last two heights, even if they jump, that it wasn't possible for those guys. So here was the distribution, and it's similar the latency to the third response. So we have here the comparison. As you can see here, the rats emitted a lot of responses. Here was not the more were emitted more responses, and you could be comparing the different height with the different number of responses. Well, that's a nice result because there are no reinforcements. But the second step, well, we have to measure the size of the rat and the hamster to do like anthropometry, but well, they are not humans. Stereometry, I don't know if that word exists, but it's equivalent. And we have the different measures of different important places that it could be useful for press the lever. At the lower lever, most of them press the lever with this pulse. So we measure all things of distances. But we take as the main measure the maximum height of the 4 pulse while rearing. They will stand against the wall. That's the distance we use for make that next analysis. This is for, well, rats and hamsters. I don't take pictures of the hamster. What? With extrinsic units. The lever height, the proportion of responses in function of the lever height, comparing rats and hamsters. We eliminate the first height for the rats because there was no comparison, there was no equivalent for the hamster. So we eliminate it, and we have here the extrinsic units. Well, the more interesting result is that intrinsic units, the maximum they coincide completely among rats and hamster, a little bit before the 1.0. So this is the P number plus the 1. Well, for us, a very good news. Affordance analysis describes unconditional level of pressure very well. So, an operant model for the lever affordance. This first part was an ecological tool for the behavioral analysis. But now we try to model affordances from a tool from the behavioral analysis. So, what was happening in the situation, in the operant situation was the time was advancing, and this is an example of well, another experiment by Schul and collaborators. He says, well, the responding is not always constant, not in a constant way. They are in bouts. The response occurs in bouts. Begin to respond, stops, make a long pause, after they begin to another trying responses, etc. So this is the analysis of inter-responses time. We thought about this idea, taking this model, and we say, okay, the rat is disengaged from the task. There is a probability to begin a visit to do press to the lever. There is a probability, once that the rat is in the place where is the lever, there is a probability to make a response and to maintain doing responses. But there is a complementary probability to abandon the response, the lever, and disengage from the task. Well, we compare this with the function of the affordances. For that, we take the Baer model. This is the exponential refractory model. It's two exponential terms in the equation, taken from Drachny, Schul, and Sanabria and collaborators. Well, each parameter of the formulation we call, say, the behavioral meaning and the ecological meaning. The behavioral meaning of delta here is the minimum time, the response time. This is in ecological meaning is a biomechanical constraint. The rat has otherwise a minimum possible to press the lever, to link the lever, and again press the lever. This is a minimum possible. It's a biomechanical constraint. The B parameter means behavioral meaning. The mean of bout initiation rate. This is an ecological meaning. The thing is an invitation to action from that object. in this case from the lever. Well, but that invitation from action is not for all the time. It has a duration. So the W is that with involved response rate, this is the effectiveness span, the time duration of where the affordance is in effect. It's not forever, it's for a while. You sit here for a while, not forever. So the Q is a probability of quitting from about after a response. This is the decline. Maybe, well, hypothetically, could be because there is another competing affordance or another activity or drug, something like that, or fatigue. There were different sources in which the organism quit from that situation. Well, the model and the data fit very well. So our hypothesis that inside the Skinner box, you could study affordances and measure different moments of the affordance. We think that this model describes very well for this kind of task. For us, it's very new. And one more step. The different parameters of the model were measured comparing the rats and hamster, but within a intrinsic metric. So it's like very difficult to find, but we try, and in some of them there are similar shapes of the parameters. So they're not perfect, but maybe some of them have coincidences. Well, this is some hypothesis that we are trying to develop from the point of view of the behavioral analysis. And with this, I go to the conclusions. From behavioral analysis to ecological psychology, and back again, we have different arguments for different theories and researchers from the behavioral analysis. For example, Peter Green says response rate is a function of number of opportunity for responding, for opportunity for action. Ecological psychology rescued and abandoned area in behavior analysis. The operation level was abandoned from the analysis of behavior. And from the point of view of the ecological psychology, it was rescued. An affordance description with the operant procedure. And the behavior analysis provides an alternative model and analytical tools for ecological psychology, or an alternative, the Bern model. Boundaries expand. Thank you.
Are there any questions?
Just because he's older.
The Bern model, the way of addressing the behavior, the intermittent behavior, I'm wondering if that intermittent behavior is Levy-flight dynamics. So Levy-flight dynamics are considered to be the universal foraging dynamics. And I'm wondering with the rat or the hamster in the Skinner box, in the absence of food, they are engaged in fairly continuous foraging. And that comes in these intermittent bursts. In fact, the graphs look like Levy flight, as it's called.
Yeah.
Yeah. No, yeah, those look rather like Levy flight.
Yeah. In fact, the Bern model was developed for reinforcement responses.
Mm-hmm.
So the rat is like the original model assumes that the rat is like looking for food.
Mm-hmm. Yes.
So it's foraging in one sense.
Yeah.
the important thing is that there is a component in that result that is not for the food, it's for the affordance of the box. You think, if you exclude things, it's not possible. But if you call exclude that affordance, is only the searching for food. It is independent of the searching for food.
Right, so there must be some other explorations going on at other locations. Yeah, right. Thanks.
We have time for one quick question.
This is actually related to what Michael was asking, but from a different angle. I spent years doing optical conditioning, and mainly with cetaceans, but also now recently with psych undergraduates, who I think are similar IQ with rats. So it's there are, outside of the box, there are the circadian boundaries of how long they've been in the box relative to what they're doing with the trainer. I mean, one of the things Skinner never understood was the importance of the trainer's hands with pigeons, which was playing with the pigeons before they went into the box, following them when they came out. And you see, I think, very different time course of behavior relative to how long they've been in the box and the actual training episodes or work episodes in the course of the day. This would be something that I think you could relatively easily include in your calculations and might provide a kind of calibration for this.
For example, here is very important to note that in the operand level procedures, more of the time the rat or the organisms are in the early times in the experimental situation because they are naive, they are naive in that setting. So the time before, the experience in that place is close to zero. And if I understand well, the question is the manipulation of the experimenter. There, yes, we have experiments with 11 hours in the box, 11 hours of the day, closed economy. This one was shorter because the rat is like there are more competing maybe affordances. There are things that the rat do. For example, sleep. After there are no more things to do, so the lever began to explore, activity of exploration. But after a while, you see the rat is sleeping. It's a very poor environment. But it was our control. We called to pin more things and observe the change of object use. This is the lever, but we could pick another object and observe the changes of the different objects. But I don't know if that's a response to the question, but please.
Okay, thank you. Thank you
Thank you.
very much.